I'm Anil Kumar, sharing with you a question on limits where we'll have indeterminate form and we'll find the limit using L'Hopital's rule. Now this one is a level 2 question, slightly difficult. It involves a lot of calculations. So I'd like you to concentrate while going through the video. We need to find limit as x approaches 0 for x cubed divided by x minus tan x. If I substitute 0 here, I get 0 over 0 minus tan 0. Now tan 0 is also 0, so we get a form 0 over 0. So that is the indeterminate form which we had been talking about. Now therefore, since we have quotient of functions as 0 over 0, we could apply L'Hopital's rule and find the limit. So now we'll apply the L'Hopital's rule. The rule really is that the limit of quotient of functions is actually same as limit of quotient of their derivatives, right? So at this stage, we will find the derivative of numerator and derivative of denominator. So we can write this limit x approaches 0 of x cubed divided by x minus tan x as the quotient of derivative of x cubed, which is 3x squared, divided by derivative of x minus tan x. Derivative of x is 1. Tan x derivative is secant square x. So we get minus secant square x, right? Now at this stage, we have applied the rule once. Now let us see if we can apply the rule second time also. If I substitute 0 here, I get 0, right, in the numerator. 1 minus secant squared 0. Now secant 0 is 1, so 1 minus 1 is 0. So we get 0 over 0. So we can again apply the rule. It is important to understand that the rule can be applied multiple number of times if you land up with indeterminate form, right? So we'll again take the derivative of both numerator and denominator and continue with our process of simplification. So the derivative of numerator is 6x. Derivative of 0, 1 is 0, and minus secant square x. So that is minus 2 secant x times derivative of secant x, which is secant x tan x, right? So that is the derivative. Now we can actually rewrite this, simplify a bit. So what we get here is limit x approaches 0. 6 over 2 is 3, so we get 3x in the numerator. We can write minus also in the numerator, right? Divided by secant square x tan x. Okay, so that is what we get. So now, if I substitute 0, what happens? If I substitute 0, I get 0 here for x, and tan 0 is 0. So we have 0 over 0 form. So we can again apply the L'Hopital's rule, right? So again, second time, we'll again apply. So what we get here is limit x approaches 0. Derivative of minus 3x is minus 3 divided by. Now here, we need to apply the product rule. Derivative of secant square x is same as we wrote earlier. So it is 2 secant x times secant x tan x, right? So times secant x tan x. So derivative of secant square x is 2 secant x, derivative of secant x, which is secant x tan x, times tan x. Okay. So that's the first part. Okay, let me extend this. Plus secant square x times derivative of tan x, which is secant square x. Okay, so that's what we get. Okay, so that becomes the derivative. Okay, that's complicated, right? So anyway, let's rewrite this as we can have secant square x tan square x. So that will help us a bit. So we have minus 3 to Okay, so actually I should have taken this 2 outside because 2 should be multiplied with both, right? Okay. Secant is 2 secant square x tan square x plus secant to the power of 4x. Now at this stage, if I substitute 0, what do I get? That is what we have to see. Now at this stage, if I substitute 0, then I know secant 0 is 1, but tan 0 is 0, right? Tan 0 is 0. So if I substitute, I get minus 3 over tan 0 is 1, right? So let me rewrite here. We know tan 0 equals to 1 and secant 0 is equals to, tan 0 is 0, secant 0 is 1, right? So 0 times anything is 0, so we get 0 here, and 1 to the power of 4 will be 1, right? So what we get here is minus 3. So the limit of this function as x approaches 0 is minus 3, right? So that is how you should be doing it. Let's go through these steps once again. First, check whether it is indeterminate form or not. We found it is 0 over 0. Apply the rule. Then again check whether it is indeterminate form. Apply the rule again. Be careful in simplifying, and then you can substitute the value and find the result. I hope this helps. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.